Myocytes responsible for focal atrial tachycardia should depolarize prior to your P wave onset. And this is because it takes a certain amount of voltage to cause a deviation from the isoelectric line on the ECG. So by the time you start to get a P wave onset on your ECG, quite a bit of muscle mass has already been recruited, which means that the depolarization wavefront has been happening for quite some time before you even get P wave onset. And so if you have depolarization after the P wave, this is not your tachycardia onset. So let's just have a look at this for a second. Here we have our myocytes responsible for focal ATAC, so they may be having a triggered activity mechanism or a micro-reentry mechanism or an automaticity mechanism. It doesn't really matter. We have a group of myocytes which seem to be spontaneously depolarizing, driving tachycardia in the heart. If we place a catheter at this location, we should detect an electrical signal during tachycardia. But at this point, compared to the ECG, so this is the ECG we have up here, and this is the bipole electrodes of our mapping catheter. If we place a catheter at the location of the focal source, we'll get an EGM, but we will not get any deviation from the isoelectric line on the ECG, because at this location, only a few myocytes are depolarizing. So our catheters are sensitive enough to detect that electrical activity, but the ECG is not, and so we should get no deviation from the isoelectric line on the ECG. If we then move our catheter away from that location into this kind of orange or yellow area, for example, where we have some electrical activity still occurring that's close to the source but not quite on the source, we will still get some EGMs occurring, so you'll probably see EGMs here, but on the ECG there will still be no deviation from the isoelectric line, because even at this location, this kind of orange location here, not enough muscle mass has been recruited to cause a deviation from the isoelectric line. So we kind of have a silent emanation period on the ECG, where depolarization is spreading outwards from our focal source, but hasn't yet recruited enough muscle mass to cause a voltage shift that's detectable from the ECG. In the kind of more green area, for example, so I'm kind of in this sort of area here, now we've recruited enough muscle mass for the ECG to detect a change in voltage, and this critical atrial muscle mass causes a deviation from the isoelectric line, and then you get P wave onset. And so by the time you get P wave offset, you've depolarized pretty much the whole atria. Maybe there's a few myocytes that still need to be depolarized in a region of scar tissue or late depolarization regions, but by the time you get your P wave offset, the majority of your atria, both right and left atria, are now fully depolarized. And so even myocytes that are very remote from your focal source are now depolarizing. And so the idea of this is that you should compare your EGM on your mapping catheter to your P wave offset. If you're getting EGMs that are occurring here relative to P wave offset, then this is late. And so this is not your focal source. No matter how good the EGM looks, this is not the origin of focal atrial tachycardia. However, if you're getting EGMs that are more in this region here, well prior to P wave onset, now this is an interesting area. We're getting close to the focal source here. And so it's good practice to compare your atrial EGM of interest to your P wave onset when activation mapping focal atrial tachycardia.